Hello guys, and welcome to the Homebrew Z80 project part 6. In this episode we're going to be looking at this, my new USB oscilloscope, and we're going to be probing the Z80 board to see what's going on. Hopefully this should make the troubleshooting a lot quicker. Let's get started. So the waveform you saw on the screen earlier was actually from the direct clock output that I've hooked the scope up to here, and then it's grounded here at the bottom, ground rail. I'm going to switch to on-screen recording, but as you may have been able to see in the intro, it doesn't look particularly good, so I think that may be causing our problems.
So we're here in our on-screen broadcast now, and I have the waveform on the screen. As you can see from the voltages and the frequency at the bottom here, it's not particularly looking that good. The frequency is fine, it's sitting at 4 megahertz, that's the speed of the crystal, so we're all good there. The issue is that the peak-to-peak voltage is around 1.8 volts, which isn't very good at all. If I drag the cursor here, you can see that at peak there to the next peak here, we do get a frequency of around 4 meg, but we get a peak-to-peak voltage is 1.937 volts, and actually for some reason it goes slightly below 0. I'm not sure exactly why that is. That may just be the slight error on the scope. However, that is not high enough to trigger the 2 volts required for TTL logic. Now I'm pretty sure this is a CMOS chip. So let me just check the voltage levels on that. So it's actually even further off a CMOS high logic level state. At 3.5 volts is the lowest voltage required for a high logic state. So there's something very wrong with this signal here. We're getting around about 2 volts peak on that clock output, which means the actual Z80 isn't going to be clocking at all, so it's just going to sit there not doing anything. Hence why when you press the reset button absolutely nothing happens whatsoever. My question is, exactly how do we sort out that issue? If I connect the probe up to the side of the clock circuitry before the final inverter, then if I drag the cursor correctly here, we can see that we still get around about 4 megahertz on the signal, and we get a peak-to-peak voltage of 2.875 volts. And so if I just move it to the input side from the actual crystal, again that's slightly different again. The issue I have at the moment is that I don't really know particularly whether that's standard or not. I have no context for this. What I will say is that I know that that's not a high enough voltage level to trigger the CMOS logic that's inside the main processor. So there's something wrong here, because none of this is going to be clocked by that, hence why we're getting no output whatsoever. So that needs changing. Just to show that the scope is actually reading correctly, this is the test point on the scope, and it's 2 volts peak to peak at 1 kilohertz. And as you can see, we're getting that measurement here. That's more to do with the way I think I've actually dragged the points then. There we go, so 2 volts peak to peak at 1 kilohertz. And we are getting that measurement. So, as far as I can tell, the scope is actually reading correctly and there's no issue with that. I have actually tweaked the pot on the side of the probe to account for the skew on the probe. So the readings I think are correct, and thus I guess I'd like to ask you guys exactly what to do about the clock signal. It's just outputting at too low a voltage, and I don't really know why. It may be something to do with the resistors I've got on that signal, on that part of the circuit right now. There's two 330 ohm resistors there. Maybe they're too high a resistance, I don't know. I need to check back on my schematic again. So, this is the original schematic of the clock circuit. The 2 inverters are there, and the third one is wired up as well. However, the difference with this particular section is this part here. That capacitor has actually been removed and just replaced with a net between the 2 points. And that is because I realised that actually the capacitor was just completely nullifying the clock signal altogether. I'm not exactly sure why I had it there. I think that was from a different schematic that I've seen. But if we look at Grant's Z80 computer schematic, I'll just put that on the screen here, we can actually see that his clock circuit is very different, and the resistor values are also very different as well. I have a 330 across this inverter, and then I also have a 330 across this one, but he's got an extremely different circuit with the capacitors there as well. So I think that needs changing, and it should produce a better clock signal. So I will be wiring that in as a different circuit to see exactly what the issue is. Although first I may try different resistors, but I think that the circuit I've got currently on my crystal is completely wrong basically and needs changing. So that's one diagnosis, and hopefully if that is solved and we actually have a clock output that actually has a peak voltage above 3.5 volts, so actually starts to clock the CPU, we might actually start to see some sort of activity. Whether or not that's helpful activity or not is another matter, but at least it'll be a step in the right direction. So I leave it to you guys at this point. I need your help once more. The comments were really great on the last video, and it spurred me on to get an oscilloscope, which I now realise I should have done a long time ago. It's a very useful piece of equipment even in this more simplistic form, and at this point I'm a little bit stuck again. I'm not so au fait with the ins and outs of actual kind of signals, clock signal smoothing circuitry, and just in general what the resistor values are for producing a nice clean signal. The signal that we were getting out there also had a lot of ring to it. It wasn't very smooth or very square at all, so that's another issue that needs solving. I'm sure the capacitors will help with that though. I need to add those on as well. It's all a learning process. I'd like to thank you for watching, and I'll see you guys in the next one.